Hi, in this video we're going to look at answering the question 6 of practice paper 2. This paper has been designed for AQA for core 1, but it is suitable for other exam boards as none of the questions on this paper have been taken from any AQA past papers anyway. As ever, for further information you can contact me on Twitter at Mr_G_Walter. Okay, let's have a look at the question then. It says a circle with centre A has the equation x squared plus y squared minus 4x minus 5y equals 59 over 4. Find the centre and radius of the circle C. Okay, so this is a fairly straightforward centre and radius of a circle question. The big difficulty that you might spot is that you've got a fraction here. So before we start worrying about it, let's just go through the same process that we would do normally. Let's get it in completed the square format, see what happens, and fingers crossed everything will work out nicely for us. So let's make a start. So we've got x squared. I like to rearrange it initially just so I've got all my x's together. So I like to have x squared minus 4x plus y squared minus 5y equals 59 over 4. And then we'll complete the square on this first part here with the x's, then we'll complete the square on the y's, and then we'll deal with collecting our like terms together at the end with our values, with our actual digit values. Okay, so let's make a start here then. So we've got x minus 2 squared minus 4. That's the first part. Plus, now I can deal with my y's. Y minus 5 over 2 squared minus, and at this point we've got to remember we're squaring this, so 25 over 4 minus 25 over 4 equals 59 over 4. Okay, what should we do next? Why don't we add our 25 over 4 here to our 59 over 4 here. So if we add these two things up, we get 84 over 4. So let's just write this bit next down. So x minus 2 squared minus 4 plus y minus 5 over 2 squared equals, and we said it was 84 over 4. And now we just need to add 4 to both sides. Now, remembering again at this point, I can't just add 4 to the top. It doesn't become 88 over 4. We've got to turn 4 into a top-heavy fraction first. So we end up doing this. So we've got 8 minus 2 squared plus y minus 5 over 2 squared. Don't worry about the 4 just for a second. Equals 84 over 4, and I'm adding on 4, but I'm adding on 4 in terms of quarters, so 16 quarters is what I'm adding on, which is going to give me a final completed the square form like this, equals 100 over 4, which is 25. Now it says find the centre and the radius. So the centre is going to be, let's have a look. So this was negative 2, so it's going to have a centre of 2 and 2.5 or 5 over 2. So we'll go for centre 2, 5 over 2. And this is centre A, so this is coordinate A. So the centre is this. It has a radius, not of 25, but of 25 squared, so a radius of 5, and it's all centred around the point A. Okay, I think I've done that. Let's just check the question again. Find the centre and the radius of the circle C. Centre, radius. Done. Let's move on to the next part. Okay, so part B says the point B has coordinates 5, 6.5. Determine whether the point B lies inside, outside, or on the circle. Now we could go about this doing various different ways. We could, if I just do a quick sketch of what's going on here. Here's my circle with a centre A. The point B, it could be anywhere, couldn't it? It could be up here, it could be up here, or it might be actually on the line. We could use Pythagoras and go about working out the lengths of these lines using Pythagoras. We've got enough information to be able to do that because we know the coordinates. So that's one possible way. Alternatively, I could try substituting these values into my equation and see what comes out. If the value 59 over 4 came out when I substituted x and y in, then we'd know it lied. We'd then know that it would lie on the circle. If it was not that, we'd have to think carefully about what that meant. But I'm sure we could have a go at substituting it in and see what happens. So the equation of the circle that we had was x squared plus y squared minus 4x minus 5y, and that equals 59 over 4. Equals 59 over 4. Now if I substitute my x value, 5, and my y value, 6.5, into here, and I get 59 over 4 coming out, then the point must lie on the circle. It meets these criteria. So let's do that. Let's go 5 squared plus, now y was 6.5. I don't like using decimals when I'm squaring. I'd much prefer to write it as 13 over 2. Because I know how to square fractions much easier and quicker and more effectively than I do dealing with decimals where I could make a mistake. Minus 4 lots of 5 minus 5 lots of, and again I'm going to leave it as 13 over 2. And let's see what this equals. So I've got 25 plus 169 over 4 minus 20 minus 5 13s are 65, so 65 over 2. Now, in order to do this efficiently, let's get it all over 4. So we've got 100 over 4 plus 169 over 4 minus 80 over 4 minus 130 over 4. And then that gives us 269 minus... Let's see, what do these two give us? 210. So 269 minus 210 is 59 over 4. And that's what we were expecting if it was to be on the circle. So we've determined, and we can just write a quick sentence, the point B lies on the circle as how can we phrase it? The point B lies on the circle as x squared plus y squared minus 4x minus 4y equals 59 over 4 as per our initial equation. Now, like I say, this isn't necessarily a way that you're always going to go about it. You could use Pythagoras, as we've pointed out over here, and then that would determine whether the length of the line was exactly 5, being the radius, or less than 5, or greater than 5, and that would have been perfectly reasonable as well. I just thought we'd show you a different way this time. Quick question then, something for you to have a think about. What if we picked a point, let's say, I don't know, let's say we picked a point that was only 1 unit away from the centre. So we're saying that this is 5 and 6.5. What if we picked 2, 2, for example? What actually would happen if we picked the point 2, 2? So 2, 2. Just have a little think about it. Maybe pause the video, see what value you get at that point. Okay, so if you substitute those values in, then you'll see that at this point you get 4 plus 4, which is 8, minus 8, which is 0, minus 10. So you get minus 10 and not 59 over 4. You've got a number that's less than 59 over 4. Interestingly, you may have done a little bit more maths and gone, well, I wonder what happens if we pick a bigger value. What happens if we pick 1010, for example? Well, at that point, we'd get 100 plus 100, which is 200, minus 40. So we're now at, what are we at now? 200 minus 40, so 160, minus another 50, so 110. We've now got a value that's bigger than this, and therefore the point would have been outside the circle. Just maybe get in touch on Twitter if you think this is always going to work, or if you can see any problems doing it this way. Okay, finally, part C says the line M passes through the points A and B and intersects the circle C at a further point P. Find the coordinates of the point P. Okay, and again at this point I would definitely get myself a little sketch going on. And let's have a think about what we know so far. Well, we know the centre of the circle, and that was at 2, 2.5. So let's say the centre was somewhere here, and the centre was point A. We know that it has a radius of 5, and point B was 5 units away. So this was 5 units up here away. And if we look at the coordinates, you'll notice that we actually end up with a right angled triangle here, because A, the change in the x direction between A and B was 3, and the change between A and B in the y direction was 4. We've got one of these 3, 4, 5 triangles. Okay, I've still not actually drawn my circle, but oh well. Okay, so my circle is going to come something like this. Okay, and what we're being asked to do is imagine that this line is being extended down here, and we've been asked to work out the point P. Here it is. Here's the point P. It's lying on both the line and the circle. Now, there is nothing stopping you at all going through the algebraic process of working out the equation of the line that passes through these 2 points. That's going to give you an equation that you can then substitute in and use simultaneous equations to work out where it will then cross the circle again. But do we have to? I'm kind of raising this question with you just to see. Because A is the centre of the circle, we know something else about the length of this line coming down here. It's also 5. And the gradient of this line is the same, which means that this must also have this same property of coming down 4 and along 3. So if we know that the point A had the coordinates 2, 5 over 2, then at the point P down here, the x coordinate is 3 less than what it was at A. We can see that from our little picture. So our point P is going to be 3 less, which is minus 1. And our B down to A was 4. So A down to P is also going to be 4 less. So we can take 4 away from this 2.5 here. Now, at this point you might want to be a little bit careful, because what you're actually doing is 5 over 2 minus 8 over 2, which is going to give you minus 3 over 2. Okay, so yes, be a little bit careful at that point, but we've got minus 3 over 2. So the point P is minus 1, minus 3 over 2. And you might think, how are the 6 marks there? Well, I think we'd also have to do a little bit of explanation about what it is we've done from this picture. So you can say, due to all the things that I said about this being the radius, and we can see that this is a 3, 4, 5 triangle, so you can use a little bit of Pythagoras there. You can say it's been repeated again because the gradient's the same. We know that the line AP is the same length as AB because they're both radiuses, both radii to the same circle. So this is this geometric way. You might need a picture and a few words, but maybe you can spot what's going on easier than you can by doing it with a load of algebra. And there's nothing stopping you from doing this as long as you explain where you're getting your values from all the way. Okay, so a geometric solution is just as valid as an algebraic one. Finally, a few revision card notes. Whenever we're doing these, just again, draw a small sketch to help you minimise any mistakes that you might make with your algebra. When you're working out circles, centres and radiuses, remember to complete the square and take real care when you've got fractions involved. It's so easy to make mistakes with fractions. Okay, as ever, read the questions carefully. Good luck with any tests or exams you've got coming up, and if you need anything, get in touch. Bye.